This video will be about change of variables in 2 dimensions with the idea of using this technique to make evaluating certain double integrals easier. So the idea is to change our region into a nicer region, or to change the function we're integrating into a nicer function by changing the variables that we're using. So before I talk about integrating anything, it's useful just to get a grasp of what change of variables means. So let me talk about one of the ways you won't be using change of variables, but this is useful to understand the idea. So I'll draw a square in the UV plane. So the square that runs from 0 to 2, 0 to 2, and I want to change u and v into some new variables and see what happens to this region. So if I switch to 2 new variables, x and y, by setting x is v minus u over 2 and y is u plus v over 2, we can see what happens to this region by plugging points u and v to see what xy coordinates we get over here. So, for example, if I start at the uv point 0, 0, and I plug that in here, what you should think of as is that I'm turning the point 0, 0 into some other xy, some other point in the xy plane, which if u and v are both 0, you get 0 minus 0 over 2, and 0 plus 0 over 2. So this point here, in some sense, gets turned into this point on the xy plane. Let's try another point. I could try one of the corners. The point 2, 0 in uv coordinates gets turned into what point? So if u is 2 and v is 0, x will be -1, and y will be just 1. 2 plus 0 over 2 gives you 1. So this point 2, 0 gets turned into that point there. And so this point goes there, this point goes there. Let's see what happens to this entire line segment. So any point on here could be described as something of the form t, 0. What do those get turned into? Well, if I plug 0 in for v and t in for u, the points that you get will be negative t over 2, t over 2. And so what line does this describe? Well, it's the line with -1 slope. As t goes from 0 to 2, it traces out this line, so that makes sense. This line segment gets turned into this line segment. And you could repeat this process for all sorts of other points. The point 0, 2, if I put 0 in for u and 2 in for v, what does that turn into? It turns into 1, 1. So this corner gets sent there. And similarly, you could check that this entire line segment gets turned into this line segment. And you could further check that this point gets sent to there. And the shape that you get is this diamond shape. So this change of variables turns this square into this diamond. A square in the UV plane gets turned into a diamond in the XY plane. Now let me mention one example of change of variables that you already know, which is polar coordinates. So if I'm on the r theta plane and I think about this rectangle, well, polar coordinates are a change of variables because they turn x into r cosine theta and y into r sine theta. And we don't have to do all sorts of computing to see what happens to this shape because polar coordinates are pretty intuitive. Namely, the angle theta goes from 0 to pi over 4 and the radius goes from 0 to 2. So the shape that we get is that region. So polar coordinates turn this rectangle into this pizza slice. And so that's another example of change of variables that you already sort of know about. Now let me talk about the more important problem of looking at some strange region and trying to view it as a simple region under a change of variables.